So good evening children, welcome to Akshara IT Foundation. This is Srinivas, your maths faculty. Let us go to the today's class. So today we are going to discuss about complementary angles and multiple angles also. Complementary angles, trigonometric identities and compound angles. Okay. So if possible we are going to learn multiple angles also. Okay. Yeah. Let us discuss about complementary angles. For example, if you take a triangle, right angle triangle here, we are using right angle triangle now. Now I am taking one of the angle is theta. One of the angle is theta. In triangle ABC, one of the angle is theta. What is the other angle? What is the other angle? Can we write this 90 minus theta? Second angle is 90 minus theta, because in right angle triangle one of the angle 90 degrees. If you take second angle is theta, then automatically third angle is 90 minus theta. According to the property of triangle, sum of three angles is 180 degrees. Sum of three angles is 180 degrees. Theta plus 90 minus theta, and this is right angle 90 degrees. So plus theta minus theta cancel. 90 plus 90, 180. So sum of three angles of a triangle is 180 degrees. From this concept, we can take, if one of the angle in a right angle triangle is theta, we can say another angle is 90 minus theta. Okay, na? Right. Now, let us see all the ratios, 6 ratios: sin theta, cos theta, tan theta, cosecant theta, secant theta and cot theta. Okay, na? So what is the ratio of sine? Opposite side by hypotenuse. So we know this is the hypotenuse. Hypotenuse always the larger side of a right angle triangle. Larger side is always opposite to the larger angle. In right angle triangle, larger angle is 90 degrees only. So its opposite side is hypotenuse. Now we are taking sine theta. So according to theta, opposite side is AB, hypotenuse is AC. So we can write AB by AC. According to sine ratio, opposite side by hypotenuse. Okay, na? Next, cos ratio, adjacent side by hypotenuse. For theta, adjacent side is BC and hypotenuse is AC. So BC by AC. Okay. Next, coming to tan theta. Tan theta, opposite side by adjacent side, AB by BC. Okay, na? Cosecant theta. Cosecant theta is nothing but reciprocal of sine. Reciprocal of sine means AC by AB, hypotenuse by opposite side. Secant theta is reciprocal of cos theta. We can say that hypotenuse by adjacent side. So AC by BC. Last, cot theta. Cot theta is reciprocal of tan theta, adjacent side by opposite side, BC by AB. Okay, na? So these are the ratios according to the angle theta. Now let us try to take ratios of trigonometric, all trigonometric ratios based on 90 minus theta. So now I am going to find sin 90 minus theta. First I have taken according to the angle theta. Now second angle I am taking 90 minus theta now. Sin 90 minus theta, cos 90 minus theta, tan 90 minus theta, cosecant 90 minus theta and secant cot. Let us check the ratios. Secant 90 minus theta and last cot 90 minus theta. Okay, na? Check. According to the sine ratio, opposite side by hypotenuse. So according to 90 minus theta, this one, its opposite side is BC. According to 90 minus theta angle, its opposite side is BC. So opposite side by hypotenuse won't be changed as it is hypotenuse AC. Okay. Cos 90 minus theta, adjacent side by hypotenuse. 90 minus theta, adjacent side, this one. 90 minus theta adjacent side is AB. AB by hypotenuse AC. Tan theta, 90 minus theta opposite side by adjacent side. So BC by AC. Cosecant theta, reciprocal of sin theta, hypotenuse by opposite side. For this, hypotenuse is AC and opposite side to 90 minus theta is BC. Next, secant theta, reciprocal of cos theta. So nothing but hypotenuse by adjacent side. Hypotenuse is AC and adjacent side is AB. Last cot, reciprocal of tan, adjacent by opposite side. Adjacent side is AB, opposite side is BC. Okay, na? Now from this we can say, actually we know that complementary angles means sum of two angles 90 degrees are called complementary angles, right? So theta and 90 minus theta. First angle is 90 minus theta, second angle is theta. Sum of two angles is 90 degrees. Then we can say the two angles are complementary to each other. So sin 90 minus theta, while you're observing the ratio, of sin 90 minus theta, BC by AC. So same ratio is here. BC by AC is available for cos theta. So from this we can write that sin 90 minus theta is equals to cos theta. Okay, na? Sin 90 minus theta equals to cos theta. Now cos 90 minus theta, AB by AC. AB by AC, compare here, AB by AC. What is that? AB by AC for sin theta. So from this we can write, this is cos 90 minus theta equals to sin theta. Once check these two, sin 90 minus theta becomes cos theta, cos 90 minus theta sin theta. So from this we can say that complementary of sin is cos. Complementary of cos is sin. Okay, let us look at for tan theta. What is the tan theta here? BC by AC. Tan 90 minus theta is BC by AC. Where is BC by AC here? Sorry, here tan 90 minus theta opposite side, BC by AB, not AC, sorry for that. BC by AB. So where is the BC by AB here? BC by AB is for cot theta. Okay, na? So tan 90 minus theta is nothing but cot theta. So sin 90 minus theta is cos theta, cos 90 minus theta sin theta. Same way, tan 90 minus theta cot 90 minus theta becomes tan theta. Check this also. Check this also. Cot 90 minus theta what? AB by BC. AB by BC means tan. Okay, na? Got it? So sin complementary is cos, cos complementary is sin. Sin 90 minus theta becomes cos theta, cos 90 minus theta sin theta. Same way, tan 90 minus theta cot 90 minus theta tan. Same way, these two also reciprocals. Just identify them. Cosecant 90 minus theta, AC by BC. Cosecant 90 minus theta, AC by BC. Where is AC by BC? Here secant. Cosecant 90 minus theta becomes secant 90 minus theta. Same way, secant 90 minus theta becomes cosecant. So sin cos complementary, tan cot complementary. Same way, cosecant secant complementary angles. Clear? This is about the complementary angles. Complementary angles of trigonometric ratios. Clear, children? Okay. Now let us see the trigonometric identities. Okay, na? Right. So let us take one right angle triangle whose right angle at B So ABC, I am taking the angle at C. Theta is the angle at C. Okay, na? Right. So let us prove that trigonometric ratios. So mainly we have three trigonometric ratios. They are nothing but sin square theta plus cos square theta equals to 1. Sin square theta plus cos square theta equals to 1. It is a first trigonometric identity. That means whatever the value in the place of theta, sin square theta plus cos square theta value is always 1. Okay, na? So theta value can be 1 degree, 50 degrees, 25 degrees, 36, whatever. If you take theta value, so this equation, that means this identity, sin square theta plus cos square theta is always 1 only. Next, secant square theta minus tan square theta equals to 1. Secant square theta minus tan square theta equals to 1. Third one, cosecant square theta minus cot square theta. Cosecant square theta minus cot square theta equals to 1. Okay, na? Yeah. So for proving this, again we need to write all the trigonometric ratios. 6 ratios we should write. Okay, na? Sine means opposite by hypotenuse. Let us see the previous one. Same diagram I have taken A, B, C. Theta I have taken at angle C. So these only the ratios. First one. These only the ratios we are using to prove that. Okay, na? Again I am not going to write again. Okay, sin square theta plus cos square theta. First one. Let us see the first one. Sin square theta plus cos square theta. So before that, we know that whenever you can observe that right angle triangle, we can use Pythagoras theorem. What is the Pythagoras theorem? Hypotenuse square is equals to sum of the squares of remaining two sides. Hypotenuse square is equals to sum of the squares of remaining two sides. So from this we can say that AB square plus BC square is equals to AC square. Okay, na? Because AC is the hypotenuse largest side. Hypotenuse square is equals to sum of the squares of other two sides. Okay, that we should use. Okay, now sin square theta. What is sin ratio here? Sin ratio is AB by AC. So let us write AB by AC. Square is there, no? Sin square theta means AB by AC whole square. Next, cos square theta. What is cos ratio? BC by AC. Cos ratio is BC by AC. So BC by AC whole square. Now apply the square for both of them. AB square by AC square. AB square by AC square plus BC square by AC square. BC square by AC square. So both the denominators are same. Then we can add the numerators. What is the numerators? AB square plus BC square. According to the Pythagoras theorem, AB square plus BC square is equals to AC square. So in the place of numerator, we can write AC square by using Pythagoras theorem. AC square by AC square, both are cancelled in one time. Because same numbers, no? Answer is 1. Okay, na? So sin square theta plus cos square theta is value is 1. Clear? Now same way, similarly we can say that secant square theta minus tan square theta is equal to 1. Cosecant square theta minus cot square theta is equals to 1. Okay. So for that also we'll use. So second identity is secant square theta minus tan square theta. Let us take this. What is secant theta tan theta ratio? Secant theta ratio AC by BC, tan theta ratio AB by BC. First let me write AC by BC. Secant theta ratio is AC by BC. So square AC by BC whole square minus tan square theta. So tan square theta or tan theta ratio is AB by BC. Tan theta ratio is AB by BC. whole square. So let us try to apply AC square by BC square minus AB square by BC square. So both the denominators are same. We can directly subtract the numerators. AC square minus AB square. Okay na? AC square minus AB square. So but Pythagoras theorem, from this we can write AB square is equal to BC square transpose that side, it will be AC square minus BC square. Or if you leave BC square this side, that means transpose AB square that side, we can write AC square minus AB square. Okay na? Now see here, AC square minus AB square is nothing but BC square only. AC square minus AB square is nothing but BC square only. So from this BC square by BC square, both are cancelled, answer 1. Okay na? So secant square theta minus tan square theta also 1. Secant square theta minus tan square theta value is 1. Same sin square theta plus cos square theta equals to 1. This is proved. Secant square theta minus tan square theta is also 1. Okay na? Clear until then? Complementary angles, sin complementary, sin 90 minus theta cos 90 minus theta sin theta. Same way, tan 90 minus theta cot 90 minus theta tan. Cosecant 90 minus theta secant theta, secant 90 minus theta cosecant theta. Clear until then everything? Yes. So let us prove this one also, then you can note together. Now, cosecant square theta minus cosecant square theta minus cot square theta equal to 1 or not. Let us check the properties, that means ratios. Cosecant theta ratio AC by AB. AC by AB. Cosecant square means AC by AB whole square. Next, cot square theta. Cot theta is nothing but BC by AB. BC by AB whole square. Same, apply the square to numerator and denominator. So AC square by AB square minus BC square by AB square. Having same denominator, so denominator is AB square and numerator is AC square minus BC square. What is AC square minus BC square value? AC square minus BC square is nothing but AB square. So we can say that AB square by AB square, both are cancelled, answer 1. So these are the 3 important trigonometric ratios or trigonometric identities. Okay na? Yeah, please note this. Please note this. Okay children. So let us discuss about that complementary angles. Okay na? Sorry. Yeah, complementary is over and trigonometric identity is also completed. Now let us go to the compound angles. Compound angles. Yeah. Right. So let us see the compound angles here. For example, compound angles means what? The combination of one or more than one angles, right? Like compound surd we have discussed in the surds topic. Compound surd means what is combination of two surds with plus or minus symbols, whatever. Okay. Same way compound angles means two angles. So for this we need to take one circle. Okay. So let us take this x-axis and y-axis like this. Okay, and we take that one radius is equals to 1 unit. Radius equals, that means here to here distance equal to 1 unit. So let this point A 1, 0 because it is lying on x-axis. The point on x-axis 1, 0, 2, 0, 3, 0 like that, right? Now I have taken here to here distance is 1 unit, 1, 0. And same way, if I take one more radius like this, This radius length also 1 unit, right? But the point is I am considering as P according to the trigonometry, the points x comma y, here x comma y, but here the point I am taking that cos theta and sin theta. So you will learn in that parametric form. Okay, na? So this value is considering as cos theta or sin theta, but if the angle is made it theta degrees angle. Okay, na? That means this is going up to here theta degrees angle. We can take this point P as cos theta and sin theta. But I am taking this angle here up to angle A. I'll take capital A. So I'll change the letter here. I'll use the letter L. Okay, na? 1, 0. So that means the angle made by that rotating ray is angle A. Here to here angle A. So this point will be cos A comma sin A. Okay, na? Now the same rotation ray going up to here. Now here to here angle is B. You know already, if the rotating ray is moving towards anti-clockwise direction, the angle will be positive. If this is going towards clockwise direction, the angle will be negative. Okay, na? Right. So here to here total angle is A plus B, right? That means here to here A and here to here B total. The rotating ray is moving from here to there means A plus B distance. That means angle is A plus B times. Okay, na? Angle is A plus B here. So then according to the point here it will be cos A plus B sin A plus B. Okay, na? Here cos A sin A. Sorry, not theta, this is cos A sin A. Cos A sin A. Okay? If the same angle is opposite, here let us take M. Same angle is opposite means anti-clockwise direction. I am taking this one B, minus B. Then what is the point here? Then the point will be cos minus B, comma sin of minus B. Okay. So I am taking the 1 unit radius. The point is 1, 0 here L because it is lying on the x-axis. And if the rotating ray is moving 1 degree or A degree angles, A angle, the point on the circle is cos A comma sin A. If the rotating ray is moving up to A plus B, then the point on the circle is cos A plus B sin A plus B. If the ray is moving from here to here anti-clockwise direction, so clockwise direction with minus B angle, so it will be cos of minus B sin of minus B. Okay, na? Right. So let us try to join these two. Okay, na? And these two. Yeah, just observe the diagrams. Q, let us take this letter O. QOL, triangle QOL, first triangle QOL, and the second triangle is POM. Now in the first triangle, OQ distance, OL distance are equal. That means here we are using that triangle rules. Triangle rules are nothing but congruency rules. Congruency rules means triple S rule, SAS, ASA. We learned in the previous classes, right? Congruent rules. If two triangles are congruent, their corresponding parts are all equal. That means all angles are equal, all sides are equal. Corresponding parts are equal. Okay? Same condition I am going to apply here. Triangle QOL and POM. Two triangles I have taken. From the first triangle, QO distance is equals to second triangle, this one, PO distance. QO equals to PO. In same way, QL or OL equals to OM. Why I can write? Because they are all length of the radius. In a circle, if you take multiple radius, all the lengths are equal only. OQ, OP, OL, OM, all are radius only now. Yeah, all radius are having equal length in a circle. Next, if there are, okay, no? And also we can take these angles here. Observe the angle here. For this QOL, angle QOL is nothing but A plus B. Angle QOL is nothing but A plus B. Same way, angle POM. POM is nothing but A minus B. But here, while you are taking a negative direction, A minus of minus B should take. Minus of minus become plus. So this is also A plus B and this one also A plus B. According to that, angle also equal. Because while you are observing that position of the angle, positions can be different but the measurement is same, right? Am I right? Yeah. So from that we can say that angles are equal. We can use SAS congruence, side angle side congruence. We can say that triangle QOL is congruent to triangle POM. So from this we can say that QL is equals to PM. QL equals to PM. Okay, no? So what is QL? QL is nothing but distance between Q to L, and PL is nothing but distance between Q to M. Now we need to use the distance formula by using the coordinate geometry. Okay, na? So let me write, if you don't know the formula, for example, x1, y1 is a point A and x2, y2 is a point B, then the distance between these two points AB equals to square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is the formula which is derived in the coordinate geometry. Okay, na? That is the distance formula. Now let us see this. Accordingly, we are having the points here Q to L. Q means what? Cos A plus B, sin A plus B. QL distance. Q point is nothing but cos A plus B, sin A plus B. And the point L is nothing but 1, 0. And the point L is nothing but 1, 0. Clear? Yeah. Same way, second one what? Point P to M. That means the distance from P to M. Point P is cos A sin A. Point M is cos of minus B sin of minus B. Point P to M is, point P is cos A sin A and point M is cos of minus B and sin of minus B. Okay, na? Now from this we have decided that in previously QL distance to PM distance are equal. So that means both the distance from Q to L is equals to distance from P to M. So apply the same formula here. QL distance, that means, QL distance. Q to L distance is square root of A square minus B square, x2 minus x1 whole square plus y2 minus y1 whole square. Same concept we have to apply here. Middle of the topic. Okay. So the QL equals to PM. QL is nothing but square root of x2 minus x1 or x1 minus x2. Anything is correct. I am writing x1 minus x2 is 1. x1 minus x2 or x2 minus x1 whole square plus y2 minus y1 sin A plus B minus y1 means 0 here whole square. That is equals to square root of PM distance x2 minus x1 cos A minus cos of minus B whole square plus sin A minus sin of, that means y2 minus y1, sin A minus sin minus b whole square. Both sides squaring, we can remove square roots. Okay, na? Now this is in the form of a minus b whole square, a square plus b square minus 2ab, a square plus b square minus 2ab. So this is 0 means we can neglect, only sin a plus b whole square means sin square a plus b. Okay, na? So that equals to here a minus b whole square. In cos minus theta also become plus theta. Why it is happen, I will explain in the next class. Okay, na? Cos minus theta also becomes cos theta. So from this, cos square a plus cos square b minus 2 cos a cos b. Okay. Same way this one sin. But sin minus theta is minus sin theta. So here minus or minus become plus, sin a plus sin b it will be. It will be sin a plus sin b whole square. Again a plus b whole square formula, that equals to, that means plus will be there now here. Yeah, what is that plus here? Sin square a plus sin square b plus 2 sin a sin b. Okay, now almost done. Cos square a plus b, sin square a plus b value 1. Why? Just now we have learned that trigonometric identity, sin square theta plus cos square theta. Theta can be any value. Same way, sin square theta, cos square theta value 1. Here already 1 will be there. Minus 2 cos a plus b. That equals to cos square a plus cos square b here. Cos square a, sin square a value 1, cos square b, sin square b value 1. First identity. So 1 plus 1, 2. Here what is remaining? Minus 2 cos a cos b plus 2 sin a sin b. Okay? Now 1 plus 1, 2. Left side 2, right side 2 cancel. Here minus 2 cos a plus b equals to, here I am taking minus 2 as a common term, then this will be cos a cos b minus sin a sin b. Minus 2 cancel both sides. This is the compound angle of cos a plus b. One of the important formula, cos a plus b equals to cos a cos b minus sin a sin b. Okay, now? So, for finding this compound angle formula, cos a plus b equals to cos a cos b minus sin a sin b, we need to prove all these things. Okay? Yeah. So, please just note it, take the screenshots for this and all. Thank you one and all. Have a nice day. Bye bye.